I'm Dhruva. Welcome back to my channel. I hope that you all are doing well and safe, healthy, and make sure that you follow all the COVID-19 precautions. Now, in this video, I will explain you all the simple definitions of motion, displacement, distance, speed, and velocity. Let's start with motion. So, motion is an action or process of moving an object or being moved. An object is said to be in motion when it moves from its original position with respect to its surroundings and time. Let's see an example. This is a bus and there is a person inside and there is also another person on the road. When this person sees this bus which is moving in this direction, he can see this bus moving. Even if he is not moving, he can see this bus as moving. So we can say that the bus is moving, is in motion with respect to this person. So therefore this person is the reference point here. We always take ourselves as the reference point by default. And when we take this person can also see this person as moving. This bus is moving but this person is not moving. Even if this person is not moving, he can see this person who is sitting inside the bus as moving. So we can say that this person is in motion with respect to this person. Here we can take this person. Here this person is the reference point. Now let's move to the next topic, distance. We will also discuss about displacement after this. And distance. Distance is the space between two things, dots, lines or etc. And displacement. After this it is displacement. So displacement is the shortest distance from the initial point to the end point. Now we will see an example of calculating the distance and displacement. This is your home, your school, this is the market, library, railway station. So you are at your house, then you go to the school. Let's assume the distance between each of these locations as 4 kilometers or 5. Between each of the locations, and when you travel from home to school and then to market, then to library, you go to library. So how much is the distance between them? 5, 5, 5. It is 15. The distance here is 15 kilometers. And the displacement is also 15. Now let's assume another case. Now you go from your house to the market and then to library. Then you again head back and go to market and stop there. So your house is the initial point and the market is the end point. Now let's find out the distance. 5 plus 5. 5. And distance does not have negative values. So we have to add another 5 because 1 5 is while going and then again coming back. So 5 plus 5, 10, 15, 20. Now the distance is 20 kilometers. And the displacement, which is from the initial point to the end point, is 10 kilometers. How did we find this? Distance does not have negative values, but displacement does. So when we head back, this is not, we don't add it. This is a negative value. When we go, it's positive. We consider this side. Now I consider it as positive and this side as negative. So while going this side from market to library, it is plus 5, and while coming back, it is negative. So minus 5 and plus 5 cancel, and only these two are left. 5 plus 5, 10. This is how we found this. So to find the, as there are negative values in displacement, this is how we find it. Now let's summarize them by finding their differences and similarities. Resistance, displacement. So distance, it is a scalar quantity. This one is a vector quantity. This needs magnitude. This does not need magnitude. This does not need direction. And this needs direction. It has no negative values. Whereas this has negative values. Distance. So as it is written here, distance can be greater or equal to displacement, but it cannot be lesser than displacement. So this is how we summarized it. Distance is a scalar quantity, displacement vector quantity, no yes magnitude, no direction, yes direction, no negative values, yes negative values. And distance can be greater or equal to displacement, but it cannot be lesser than displacement. Now let's see speed. And we will also look at velocity. First it is speed. Speed. Speed is referred as the rate at which an object covers given distance. And velocity, it is a simpler word of speed. Speed is calculated as distance by time. We will know about it. Now let's take an example. This is a person. He travels 100 meters for some 2 minutes. This person travels 50 meters for 2 minutes. This is also 2 minutes. No, we will take it as 1 minute. I'll take it as 3. Okay, what can we compare in these both situations? We can't compare the distance because it's not same. We can't compare time also, the time they took. 2 minutes and 3 minutes are obviously not same. So we can't compare that also. But there is one thing which we can compare in these both, that is the rate at which the rate of the distance covered by them per minute, something like that. Yeah, we can see that as a common point. So to find the rate at which the rate of the distance covered by them for a minute, we can find that by dividing distance by time, that is distance 50. Let's take first one, 100 by 2 minutes. 50 meters per minute, and the second person, and something. So here we can take it this like this, 16 point, wait a second, 16.66 meter per minute. We can see the speed at which they covered it. So now when we compare this, we see this this person who is faster. Now you are the person who have to select someone from your team who can run faster. Whom will you select? The person who can run 50 meters per minute or 16.66 meters per minute. Of course you will choose the first person because he runs faster. And this rate which we found out, the rate at which they run for a minute, is the distance covered by them in a minute, is nothing but speed. So by this we can know the formula of speed, which is distance by time. Speed is equal to distance by time. Now we will move to velocity. Okay, now we will move on with this velocity. As I said earlier, velocity is the simpler form of speed, and it actually is as same as speed, the way we calculate velocity. But there is a slight difference. Where we use distance for speed while calculating, we have to use displacement for velocity. Now we will know how it is. We'll see an example. This is Hyderabad, Delhi, and this is Punjab. Let's assume the distance between all these three locations as 300 kilometers. So now when you travel now you're at Hyderabad and you'll travel from Hyderabad to Delhi, then to Punjab, then again you will head back to Delhi. So Hyderabad is your initial position and Delhi is your final position. Now when we calculate the distance, it is 300 plus 300 plus 300. It is 900. And when we calculate this displacement, it is 300. You all know how to calculate displacement by now, right? So now let's calculate speed and velocity. Speed, distance by time. Okay, so the time taken by these people to complete this journey is some 6 hours. Distance by time 900 by 6. So the speed is 150 kilometers per hour. Now let's calculate the velocity. Velocity is displacement, which is 300 kilometers. 300 kilometers by time 6 hours. So the velocity is 50 kilometers per hour. You can see the difference, right? The speed and velocity are not the same, and the formula is also different. Here it is distance by time, and here it is displacement by time. Now let's summarize it. Let's summarize it by finding its differences and similarities. Speed. It is a scalar quantity. And velocity is a vector quantity. Here in the formula we take it as distance, right, in that place, and here in velocity. In velocity we take it as displacement. And velocity it's a simpler word. Velocity is a simpler word for speed, and speed is a scalar quantity, velocity is a vector quantity, and in the formula we see this. In that place we use distance, and here in velocity we use displacement, and velocity is a simpler word for speed. So that is it for this video. I hope you liked it. If you did, give it a like, share it with your friends and family, and subscribe to my channel. Thank you. Stay home, stay safe.